Hello everyone, Sayan this side, and today we are going to study the third week of our Statistics 2 course, as you can see. And in this in this week, we will be studying about a very known topic. You know it already. That is nothing but expectation, then variance, covariance, and correlation. Okay, you know these topics already because you have covered these topics in Stats 1. I mean, maybe you have not covered up covariance or correlation directly in as of probability, but you have covered them as sample and population, right? So how did you cover them? You remember some formula 1 by n summation I equal to 1 to n xi minus x bar into yi minus y bar. Yeah, this is nothing but what? Covariance. Okay, and this is for the population covariance, and 1 by n minus 1, and then the same thing you will be writing it again, xi minus x bar into yi minus y bar. So this will be sample covariance, right? So this is something that we'll be studying it once again. Okay, so nothing to worry about. You know these things, and to be very honest, questions from covariance and correlation are not asked, especially in your week 1, 2, 3, and 4, or especially in your quiz 1. However, these topics are there. We have to cover them. Sir has taught them. So that's the main reason we are covering it. Okay. So, okay. Without further ado, I guess we should get started. Okay. So, expected value of a random variable. We can often denote it as E of X. Okay. Now, what is this? First of all, as the name suggests, expected. Okay. Let's deep dive into what is the meaning of expected. You give an exam. Okay. You give an exam, and the exam it went good. Okay. Say it was of stats 2. You studied from me, so it will be going good. Just kidding. Okay, so you have given the exam and it went good, and there is a probability of say 80% that you will get say 100, and you might have committed some mistakes. I did the same as well during my exams, especially for stats 2. I committed one question wrong, and I missed my 100 in the end term. I got 93 if you remember. And similarly, there is a 20% probability that you think that you will get say 95. Okay, say that question was of 5 marks. And since the stats 2 paper is a memory based paper, and all the other quizzes and end-terms are memory based, or I can say CVT, so you are not sure that if the answer is correct or not because you're not able to verify it. But you think that there might be a 20% chance that you might have committed an error in one question. So you come home, okay, you come home, and your parents ask you how much are you expecting? Okay, not your parents, your friends can also ask you. if I am lucky enough to get in contact with you guys, then I may also ask you that how much are you expecting? Because this is something that we will be analyzing when your result comes out. Okay, how much increase has it been? How much decrease has it been? These are the rest of the things. Keep this example in mind. Okay, all right. So your parents ask you how much are you expecting. Now what do you do? You say that mama or papa, I have attempted 100% questions, out of which I do think that there is a 20% error chance that makes me a probability of zero point 0.2 that uh, just a minute, there is one mistake in here, or I can say just, oh, shit, just a minute. Yeah, I can say it like this. Okay, there's a 0.2% error that I'll be getting 95, or 0.2% probability, or 0.2%, not 0.2%, 0.2 probability that I'll be getting 95, and an 80% that is a 0.8 probability that I'll be getting 100. Have you understood or have you learned about something known as PMF table in your stats 1 or in the previous lectures that we discussed? The answer is yes. Have you understood something about constructing the PMF table? Yes, you have. So, if I define a random variable x that stores how much will you score in your paper, then I can design a probability mass function table because these values are discrete. So, probability mass function will exist and not the probability density function. We'll be studying that in the later week. That is in the week 4. We'll be studying it in the concurrent week. So now either x can be 100 or x can be 95. And now the probability that x will be either 100 or either 95. What is the probability that x will be 100 according to you? It's 0.8. Okay. What is the probability that x will be 95 according to you? It's 0.2. Now forget this PMF table for just an instance. What would you do if you didn't know about expectation? You would say, okay, in 80%, uh, sorry, 80% is my probability of getting 100 because I'm 80% sure. So I've attempted 80% questions correctly, and there's a 20% error chance. So maybe I'll be 20% sure of getting 95. You'll be doing something like this. And the same thing, coincidentally, the same thing we'll be doing right here. Okay. So what do we do? What is expectation? Or now we'll be getting the crux. We'll be doing something like 95 into 0.2 plus 100 into 0.8, and I can assure that you will be a very good chap if you get a score like this in stats 2 because it's tough. Stats 2 and maths 2 are nevertheless tough. I told it to you before. Okay, so I've got my calculator. You'll be having it on your screens or you'll be having it with you by this time. You're expecting then 99. Okay, you're expecting that you'll be getting a 99 out of 100. Oh, a great start, a great amount of mark, to be very honest. Okay, so now if we go into the definition part, this is an instance that I have told you. Okay, so if we get into the definition part, what will it be? Let me write it with another color, and everything that I'm writing with yellow is something that you should include in your notes. And these are the things that you should only take up as an example for the theory part. Okay, so the average value a random variable takes during its long run for each probability corresponding to its value is called the expectation of the random variable. Okay, now what does this mean? This means only this part. This part uh, summarized in English. Okay, how? Let's see. The average value that a random variable takes during its long run for each probability corresponding to its value is called the expectation. So average value, it is nothing but, you can say that your parents are asking you how much are you expecting, or they are asking you that um, how much will you get on an average. Okay, they are either asking you expecting, or they will be asking you on an average, right? Nothing more. So this is the average value. And if you take up the probability, for example, probability, what is probability? Probability is nothing but total number, sorry, favorable outcomes divided by total outcomes. This is something that we know from the frequency definition of probability. So if you are writing something around 100 into 0.8, it's as good as writing 100 multiplied by 80, or say if there were how many questions are there, 20 questions maybe. During our time there were 20 questions, so you are writing something around 100 into 16 by 20 plus 20, not 20, 95, yeah, eraser. You're writing something as good as 95 into 4 by 20. So what does this mean? You're 95% sure that this question, that these four questions that you have attempted, they are correct, and you are 100% sure that these questions that you have attempted are uh, correct. Okay, so this is all, that when you do the average, this is nothing but the average case, right? When you calculate this, you'll be seeing that it's average. Okay, all right. So that is something, because these are the values that your random variable will actually be taking at the frag end of the day, when it will be going through all the values that it can take in its range. Okay, so this is something that is called the expectation of that particular random variable. Now about its formula. Okay, I just changed my pen color, sorry. Yeah, the formula for expectation of random variable e of x is summation of I equal to 1 to n xi into probability that x equal to small xi. This is something that you have studied in stats 1, but still I'm explaining it to you. What have I done here? Xi, it's 95, corresponding probability 0.2. I have producted the same thing. This thing has taken place. Then 100 into its corresponding probability 0.8. I have done its product. This thing has taken place. I've added them together and I get nothing but my so-called average value, or my expectation. Okay, so this is all about the theory portion of expected value of a random variable. You don't need to understand or study anything more than these things in the theory part. But yeah, there are questions, because you'll be asked questions in your quiz 1, quiz 2, and your interim examinations. So let's move on to some questions. Okay. the first question. It says, by investing in a particular stock, a person can make a profit of either 10k in 1 year with a probability of 0.55, or take a loss of 5k with probability of 0.45. What is his expected gain? Now, in these type of questions, either the random variable defined for the particular event will be mentioned to you, or you have to figure it out yourself. And you can see that this is something that asks you to figure the same out by yourself. How will you do it? You see, investing in a particular stock, a person can either make a profit of 10k with the probability, or take a loss of 5k. So loss of 5k isn't as good as a profit of negative 5k. Yes, it is. Okay. So if it's as good as the loss of negative 5k, or sorry, if it is as good as the profit of negative 5k, then I can say that let x denote the profit made by the person, right? Okay. So the range of x tx, what will it be? Either it will be 10,000, or it will be, or let me just remove the comma from here because understanding might be fluctuated by this case. Okay, 10,000. If I put the correct zeros, yeah. Okay, and then a loss of 5k. So if x denotes the profit, as I told you, the profit will be negative 5k. So it's negative 5,000. As simple as that. So x will either be taking rupees 10,000 as the profit, or it will be taking rupees negative 5,000 as the profit. Okay. So if we construct its PMF, as I told you, if you get something related to discrete random variable and you have to find its expectation, variance is this, that, a hell lot of things, it's always a good practice to construct its PMF table. So let us construct its PMF table and let's find out. Okay. So if it's x in here, it's 10,000 and it's negative 5,000. And probability x equal to small xi. And what is xi? This is 1, and this is x1, this is x2. So what is the corresponding probability to this that is given to us? It's 0.55. Okay. So let's write it down. And what is the probability of the loss? It's 0.45. All right. So let's write it down as well. Okay. So this is done. Now we have to find the expectation of x. Pure formula based question, as I say, from I equal to 1 to 2, because there are two random variables in here. Oh, sorry, two values that the random variables take here. And this is xi into probability of x being equal to xi. So if I break this, I mean I should not, but still, for the sake of completeness and for the sake of understanding of you people, if you have not understood it by now, it is something like this. Okay, so just put 10,000, what the hell, 10,000 technologia. Okay, x equal to 10,000 plus, sorry, not plus. Okay, you can put plus here, but okay, let's just plug the values into the formula first, and then we will be solving it mathematically with the help of integers and basic addition and subtraction. So x equal to negative 5,000. Okay, so 10,000 into probability. What is this corresponding probability? It's nothing but 0.55. And what is this probability for negative 5,000? It's 0.45. As simple as that. So This will be nothing but 5500 if I am correct. All right, I am. Okay. And what will this be? I have my calculator in hand. 45 into 5, it's negative 2. Um, sure. Okay, I forgot it. Let me calculate it once again. 0.45. So it's 2250. 2250. And if I calculate, because I don't believe my calculations, these are the very things that led me to lose that precious 7 marker. Okay, so yeah, it's 5550. And if we subtract it, sorry, 5500 minus 2250, it's nothing but 3250. Therefore, expected profit is nothing but 3250. Wherever you see expected, just close your eyes and write expectation of x. Nothing else. Okay. All right. So this is an easy question, right? Okay. The next question. Suppose a random variable x is given with its distribution. Find expectation of x. And as you can see, the last value has become the first in here. So I'll have to write it again. Okay. I'll be writing it. So what is the table that is given to us? It says x equal to 0, x equal to 1, x equal to 2, probability of x equals small x I, then 3 by 16, no, sorry, it's not 3 by 16, my bad, it's 1 by 4, it's 2 by 4, and for this case it's 3 by 16. Okay, now we have to find the expectation of x. Isn't this the same type of problem that we had done in the previous slide? So should I do it or should I give it to you as a homework? Let's take it as a homework. Okay, let's take it as a homework and do comment down the answer with the help of the timestamp with this corresponding video. I don't know what will be the timestamp because I am not interested to know it right now. Okay, all right. Okay, and I've given you the PMF table. Just let me do one thing. Just let me help myself out by making it even clearer. Probability x equal to small x I. Okay, all right. Yeah, not as good as this, but at least it's correct. Okay. Then the same question. Okay, this is also a homework because there's nothing new in this place. Okay, let me just write down the PMF table for you guys again. I don't know how long will this go and how will I be able to change it. I mean, this glitch is literally killing my time as well as your time. So, okay, it is what it is. 3, 4, 5, 6, 7, 8, 9. Probability x equals xi. Then half for this case 1 by 24, 1 by 6, 1 by 24, 1 by 4, 1 by 6, and then 1 by 4. Okay, all right. So please do follow this PMF table, although if you want then you can follow the next as well because the probabilities regarding to the corresponding values have not been changed till now. That's something I consider the almighty god for. Okay, so this is the PMF table, you can refer to it, and yeah, again comment down the answer. Okay, all right. Now another question. A coin is biased in such a way that the number of heads is likely to occur 3 times more than the tails. Find the expected number of heads when the coin is independently tossed 4 times. Alright, something new. So let's get on to it. Okay. Here the coin it's biased. Okay. Such that the probability of heads such that x is likely to occur 3 times more than the tails. Okay, all right. So I have to find the expected number of heads when the coin is independently tossed 4 times. All right. So how should I do it? You see, my value of tails is not directly given, neither is my value of heads. And my value of heads, it depends somewhere on my value of tails. Okay. So what if I do something that I take the probability of tails to be head, no, sorry, x. Okay. So let probability tails equal to x. So probability heads equals 3x. And as we know that either a head or a tail is the value that a coin can take, or a random variable defined for the coin can take if this is 1 and this is 0, and their values will be adding up to 1. So 3x plus x will be equal to 4. Sorry, not 4. What the hell have I written just now? I mean, wow. Uh, yeah, 3x plus x equals 1. Then 4x equals 1. So x equals 1 by 4. Okay, yeah. Therefore, probability of tails, it's nothing but 1 by 4, and probability that heads occur, that is 3/4. Okay, all right. So it tells me to find the expected number of heads when the coin is independently tossed 4 times. Okay. So can you see, it has told me something, expected number of heads. This has very important data hidden inside it. What is it? Let's see. You see, when I'll be tossing a coin 4 times, what will a random variable x that is defined for the number of heads take? What values will it take? It will take some value 0 if all the four heads are, sorry, if all the tosses yield me tails, 1 if 1 yields me heads, 2 if 2 yields me head, if 3 if 3 yield me heads, and 4 if all the 4 are heads. So this is the range of the variables. Okay, all right. But for probability x equal to 0, you see, I have to count the number of successes. Okay, I've got to count the number of successes because this is number. So count number of successes. These can be either 0, then 1, then 2, then 3, then 4. Okay, so I have to count the number of successes, and I have been given independent trials. Okay, so we know that independent, or I should say Bernoulli trials. Just a minute. Yeah, Bernoulli trials plus n times, that's nothing but a binomial distribution. Yeah, binomial distribution. Why and how am I getting its intuition? Because I have to count the number of successes. Bernoulli only tells you if one thing is a success or is a failure. But binomial distribution defined for the variable, or if a variable follows binomial distribution, it tells you the number of successes. These two are the things that will be useful to us. They will be coming in handy to us more than any distribution. So I request you to remember this trick. Okay, all right. So it tells me the number of successes, and that's something which my random variable x, it follows. So What is the PMF of binomial distribution? Although I have it written in here and I don't know it, so let me just see it. Yeah, okay. What is it? And are we allowed to see it? So I've taken it right from your paper, the same paper that we used to get, or the same question number 2 that we used to get. Okay, so it's nothing but nck p to the power k 1 minus p to the power n minus k. Okay, so let me erase it because I'll be giving it to you. Yeah, it's included in here if you are not able to find it in the other places which I've already told you. Okay, so what is the value? What is the PMF? It's ncx x to the power, sorry, not x, p to the power x, yeah, p to the power x 1 minus p to the power n minus x. And what is x? The number of successes. What is p? The number of, sorry, not the number, the probability of success. So for this case, if I substitute these values, it's 4c0. What is p? P is 3 by 4 because this is my success, right? So 3 by 4 to the power 0, 1 by 4 to the power 4 minus 0. So this is nothing but 4c0, 1 by 4 to the power 4. And we know that 4c0 is nothing but 1 because you're not picking up anything from 4. So there's only one way that you are not picking up anything. So 1/4 is to the power 4. Okay, all right. Probability that x equal to 1. What will this be? Just plug in the values. 3 by 4, 1, 1 by 4, 3, 4c, 1, 3 by 4, 1 by 4, 3, oh, sorry, did I just write it twice? Pardon me. So this will be nothing but 4, 1 by 4, 3, 3 by 4. Okay, you don't have to calculate these things. It's as good as not calculating. Okay, if a probability x equals to 2, what will this be? 4c2 to the power 4 2, 1 to the power 4 2, sorry, 1 by 4 2, and 3 by 4 to the power 2. Okay, so what is 4c2? I don't know that again as well. You should accept if you don't know things. That actually gives you some confidence. Okay, so it's 6 into 3 fourth 2, 1/4 to the power 2. Okay, then probability x equal to 3, that is 4c3, 3/4 to the power 3, 1/4. So 4c3 NCR equals NC n minus R, so it's nothing but 4. Basic property. Okay, so 3 by 4 whole cube 1 by 4. If a probability x equals 4, that is nothing but 4c 4 3/4 to the power 0, sorry, 3/4 to the power 4, 3/4 to the power 4, 1/4 to the power 0. So this is nothing but 3/4 to the power 4. So if I form my PMF table right now, what will be my PMF? Okay, now this is going to be a bit lengthy because you can see that I have not calculated these values. So it will be a bit spacious for me. Okay, probability x equals xi in here, it goes in this place. So it's 0, then 1, 2, 3, 4. Okay, so for 0, what is it? 1/4 raised to the power 4. For x equal to 1, what is it? 4, 1 by 4 to the power 3 into 3 by 4. Then it's 6, 3 by 4 whole square, 1 by 4. Then what is this? 4, 3 by 4 whole cube. Turns out that I have not taken up enough space. Then okay, what should I do? This is all that was providing me some amount of space. Okay. Okay, so this is the PMF table. This is my PMF table. Okay, I have built my so-called PMF table in here. And what should I do right now? Just apply the formula. Expectation of x is equal to summation I equal to 1 to 4 xi p of x equals xi. So what is this? It's 0. And what is for this case 4 into 1/4 whole cube 3 to the power 3/4 plus 2, not 2, let me write it directly as 12. Okay, so 12 3/4 squared 1/4 plus 3, or again, why am I doing it? Okay, so 12, am I doing it correctly? Yeah, I am. So 3/4 cube 1/4 plus 4 into 3/4 to the power 4. So this will yield you some value. I'm not calculating it as the answer. And if you do find the answer, because I don't have it written in front of me, and I should not have it written in front of me, so again, do comment it down with the timestamp. Okay, all right. So this is a good question, a hell lot of concepts you can see, but it's easy, I would say. Why is it easy? You know the trick, you know the number, you don't have to do anything else. Just apply binomial and you are done. Okay, all right. Another question. The probability distribution of a random variable x is given by 4cx 1 by 4 raised to the power x into 3 by 4 raised to the power 4 minus x. Find the mean of x if x takes the values 0, 0, 1, 2, 4. Okay, what is the PMF that is given to me? Probability that x equals xi, that is given to me as 4cx 1 by 4 raised to the power x into 3 by 4 raised to the power 4 minus x. Hey, have we done something like this? Have we just seen the format? Yes, we have. This is p, and so this is 1 minus p. Okay, and what is this? This is n. And let me remind you, even though you have studied it, but it's my duty to remind you guys that this very gentleman has its mean as np. Okay, so what should I do right now? For this case, my n is 4, p is 1/4, therefore np is nothing but 4 into 1 by 4, that is 1. So the expected number of, you can say, if you relate it to the previous questions, the expected number of the expected number of heads that the coin can produce on 4 tosses is only 1. Such a low probability. But okay, not everyone is born to shine. Human life and coins are disgraceful. Okay, so just kidding. So it's expectation of x equals 1. Second, find the expected value of a discrete random variable whose PMF is given by 1 by 16 4cx, x equals 0, 1, 2, 3, and 4. Okay, let's do it. Although it's a simple one, we have done a question much difficult than this one. Okay, but still, let's do it. X equals xi probability. That is, what is it given? 1 by 16 4cx, and that's it. Nothing else in the this part. So it's not a binomial distribution. This will always yield me a number, so it can happen. Therefore, let's write down the formulas, or let's write down the values before actually putting them into our PMF table. So when probability of x equals 0, because xi will either take 0 or 1 or 2 or 3 or 4. Okay, and that's it. That's all I have to do. I have to just substitute the values of xi in here. So 1 by 16, 4C0. So that is 1 by 16. Probability x equals 1, that is 1 by 16. 4C1, that is 4 by 16. And I'm keeping the denominator constant. You'll get to know it within a few minutes. And if you know it already, then congratulations. X equal to 2 is 4, sorry, not 4, it's 1 by 16 into 4C2, 1 by 16 into 4C2, and if you remember, that's nothing but 6 by 16. Then probability x equals 3, that is 1 by 16 into 4C3, that is nothing but, I guess, 4 by 16. Therefore, probability x equals 4, that's again 1 by 16 into 4C4. So that is 1 by 16 again. Okay, all right. So the PMF table for this case is nothing but this 0, 1, 2, 3, and 4. In probability x equals xi. For 0, it's 1 by 16. For 1, it's 4 by 16. For 2, it's 6 by 16. For 3, it's 4 by 16. For 4, it's 1 by 16. Therefore, expected value. Okay, something known to us very well. So it will be 4 by 16 plus 12 by 16 plus 12 by 16 plus 4 by 16. So 4 plus 12, 16, 12 plus 4, 16, 16 plus 16, that's 32 by 16, and that's 2. Answer. Okay. Oh, this looks, oh, again, some mistake in here. Okay, now it's okay. And this looks like 8, but it's not 8. For confirmation, it's 6. So the answer to this question is 2. Okay. Now, properties of expectation. What are the properties of expectation? A very simple property. Okay, not one property. There are approximately 3 properties that are simple. First property, expectation of C times X, or capital X, where C is nothing but a constant. That is, C pops out and it's expectation of X. What does this mean? Suppose a seller has to sell a phone, okay, and he has got an expected profit of rupees 3700 on each phone. Okay, so if I ask him the expectation of 10 times or 10 phones, then what will he say me? 10 times the expectation of profit in my each and every phone, right? That's something that has been done here if you can see it closely. I have not defined any other variable. I could have defined it, but what's the need of the same, right? Simple property, just simple multiplication related with this example. You are good to go. Okay, so this brings us to the end of the first property, which is, yeah, at times heavily used. The second property. What is the second property? That expectation is distributive over addition. That means expectation of x plus y is equals expectation of x plus expectation of y. And this is something that you should remember. Okay, this is something that you should remember. Why am I telling you? Because in large cases, when you will be studying week 7 or maximum likelihood estimation, not maximum likelihood estimation, method of movements estimation, These are the small and tiny bits and pieces that you will have to apply directly, and at that point of time you won't be finding out how to apply it. Okay, so I'd really request you that please, please do start thinking in that direction. And if you uh, stay on with me till the seventh week or till the ninth week when we will be applying these things extensively, I will be recapitulating all of these things in front of you. But if you understand these things, then it's better for you. Okay. Then the third property, expectation is linear in nature. What do I mean? Expectation of a times x plus b times y, where x and y are random variables and a and b are nothing but constants. What does that do? It distributes over the plus. Okay, we know it, right? We know it. How does it do? Let's take a glimpse of that as well. Okay, although you will be able to do it easily, but still, let us actually do the proof, or else it does not feel complete, to be very honest. Okay, so ax plus by. Let's take ax to be some random variable w and by to be some random variable z. So what does this become? This becomes e expectation of w plus z. Have we seen that whenever there's a plus, expectation distributes over it? Yes, we have. So it's e of w plus e of z. Now what was w and what was z? That was expectation of ax for w plus expectation of by for z. And have we studied that for a constant, expectation distributes, or expectation not it does not distributes, it pops out the constant. Okay, it has got some dimension issues, so it pops out the constant, and we have got something like a of ex plus b of ey. Okay, so ultimately what you have to remember is not the proof, not anything related to the proofs. Okay, ultimately what you have to remember is this result, a of ex plus b of ei. Just let me write it down for you so that you have it accumulated at all at a single place and you never visit it. Sorry, I should not say this. You do. Okay, people who are serious, they do. So this is something that you should remember. So these are the three properties of expectations which will help us to get a clearer overview. Okay, now how? Let's do some questions. Maybe this question is not related to um, the properties, but still let's do it because it has got something new, some simultaneous equations with it. Okay, what does it say? It says suppose a random variable takes values 2, 3 and 4. If expectation of x equals 3.4 and probability of x equals probability of x equals 2 is equal to probability of x equals 3, then find the value of probability of x equals 4. Now how to deal with these things? Okay, first let's do something. Let probability x equal to 2 equals probability x equal to 3 be k, some constant, some value k. Okay, so PMF table, what will be the PMF table? This will be nothing but x and the corresponding probability to x. So this will be 2, this is 3 and this is 4. Okay, all right, simple. Then if it's k for 2 and 3, then I'll be just substituting k in 4, right? That's not a very hectic task. And now let probability of x equals 4 be p. Okay, then this is p for this case. And we know that each that the sum of these entries in the PMF table in the probability part, that should be 1. Therefore, k plus p, that should be equal to 1. So 2k plus p, that should be equal to 1. This is our first equation. We mark it as number 1. And it's given to us that expectation of x is 3.4. So E of x is equal to 2k plus 3k plus 4p, and that is nothing but 3.4. So 5k plus 4p, that is equal to 3.4, and this is our second equation. Now I hope that you have studied how to solve simultaneous linear equations. So if we adjust them by some method, I can see that p can get cancelled out by hook or by crook, or you can cancel out 2 as or k as well. But let's cancel out p first. So 2k, not 2k. If I multiply this entire thing by 4, then 8k plus 4p equals 4, and 5k plus 4p equals 3.4. Okay, so subtracting these, we get 3k equals 0.6, or k equals 0.2. And now, since k equals 0.2, if I put it in this equation, then 2 times 0.2, sorry, just a minute. Yeah, 2 times 0.2 plus p equals 1. So 0.4 plus p equals 1. So p equals 0.6. Understood? Yeah. Therefore, x and 2, here 3, and here's 4. Probability of x equals xi. That is 0.2, 0.2, and 0.6. And if you add these things up, you'll be seeing that it's 1. So the values are correct and completely authentic, and they match the case. So what was asked to us? Value of probability of x equal to 4. We know this already. What do you think of this? It's 0.6. Right? Yeah. And that's the answer. That's the normal answer. Simple as that. Or if you wanted, then you could have just multiplied it with 5 and this with 2, but this would require twice the multiplication, and there's a decimal point, so twice the error as well, twice the chances of error. Especially we are studying statistics and probability, we talk about chances. Okay, all right. Now, question number 2. Let x be a discrete random variable following the PMF this. At least this came out to be correct. Thank God. Okay. Define y equals x minus 1 into x minus 2. Find the expectation of y. Let's do it. X minus 1, x minus 2 is equal to x squared minus 2x minus x, x squared minus 3x plus 2. Therefore, the expectation of y is equal to expectation of x squared minus 3 expectation x plus 2. Oh, and one more thing. Expectation of c, a constant, is nothing but c. Okay. So, what will this be? Expectation of x whole squared minus 3 times expectation of x plus 2, and that's where people commit the biggest mistake of their life and they lose marks. I told you guys that it's distributive over addition and subtraction. Did I tell you that it was distributive over multiplication? No, it is not. So what do we have to do? What do we have to actually change for this case? We have to go by our old school method, which we have done at some time in stats 1. So we will be doing that thing, that very gruesome and tiring thing. Yeah. What have we been given here? Sorry, not the red pen again. So eraser. Yeah. We have been given y equals x minus 1 into x minus 2. So the values that y can take, so range of y, what will this be? When x equals 0 for both the cases, it is 0. No, not 0, it's 2, right? Minus 1 into minus 2. For 1, it's 0. For 2, it's 0 again. So this will be 0.3, sorry, not now. We'll be discussing it in the later parts. And for 3, it's 3 minus 1, 3. Sorry, it's 3 minus 1, 2. And then 3 minus 2, 1. So it's 3. Okay. So this happens, when this happens, the probability for this thing is only probability that x equal to 0, right? Okay. So the probability for this case is 0.2. So this is y and this is probability of y. Okay. For 0, so it will be 0 minus, sorry, for 0 it is either 1 or 2. So if we know probabilities for the odd case, either odd case, they are added. So 0.3 plus 0.4, that's 0.7. And for this case, for 3, it's nothing but 3 minus 1, that's, oh, sorry, just a minute. It's me who is at fault. I beg your pardon, 3 will never be a value. Yeah. So 3 minus 1, that's 2, and 3 minus 2, that's 1. So it's 2 again. So for this case as well, the odd part is coming up. And since the odd part is coming up, this will also be added. So my entire value for this case is nothing but 0.3. And if you are unsure, you can add these values up, they will result in 1. So our values are always correct. Okay, our values are correct for this case at least. All right. Therefore, for y, do I need to make the PMF table right now? I've got the values and the corresponding probabilities. No, I don't want this much labor anymore. So expectation of y, that will be I equal to 1 to, sorry, yeah, I equal to 1 to 4. What the hell am I doing? Where is my concentration? Yeah, 4. Xi into probability, capital X equals Xi. So this is, oh, sorry, this will be 2, right? Okay, so xi, it's 2 into 0.3 plus 0 into 0.7, cancelled out to 0. So 0.6 plus 0 is 0.6. Therefore the expected value of y is nothing but 0.6. Okay, that's it. That's enough for this question. Then the joint PMF of the random variables x and y is given as y here, x takes the values in this place, y takes the values here. So for this case, what do we have to do? Define a random variable z equals to x squared. Okay, this is x squared and this is 3xy. Find the expectation of z. Okay, so what do I have to do in here? Z equals x squared plus 3xy. So again we have to go through that old school method. What old school method? We have to find each and every value of z and then we have to substitute it. So for z, then for x in here, then for y, and then the corresponding probability. Oh shit, this looks so ugly, so unspaced. Okay, then y, then the corresponding probability to z. So x, for x being 0, it's 0 0 0 1 0 2, then 1 0 1 1 1 2. Okay, all right. So x squared plus 3xy, z is 0. X squared plus 3xy, z is 0 again. So let's add these things up. Okay, so for 0 0 and 0 1, what is the value of 0 0? 0 0.1. Then 0 1, that is 0 0.2, 0 0.2. Okay, and then it's again same, 0 2. So 0 0.1 plus 0 0.2 plus 0 0.1. What is it? 0 0.2, 0 0.4, 0 0.4. Okay, yeah. So probability of z for this case is done, and it's 0 0.4. So probability of x or probability of z for x squared plus 3xy, what will this be? 1, right? Okay. So for 1, it will be, what is the probability? 1 0, x equals 1, y equals 0, it's 0 0.15. Then 1 squared plus 3 into 1 into 1, so it's 4. Okay, so what is the probability for 1 1? 1 here and 1 here, it's 0 0.3, 0 0.3. And one more value, that will be 1 2. 1 squared plus 3 into 2 into 1, so 6 plus 1 7. And similarly, if I calculate its probability, 1 2, that is 0 0.15. Okay, and if you have got any doubt, feel free to check it out. 0 0.4 plus 0 0.3, 0 0.7 plus 0 0.3, 0.10. So sorry, not 0 0.10, 1.0. So the thing is done. Therefore, probability z equals to small z, that is 0 0.4 when z equals to 0, 0 0.15 when z equals to 1, 0 0.3 when z equals 0, z equals 4, and 0 0.15 when z equals 7, right? Yeah, and 0 otherwise. You don't have to mention that. Many people do mention it, but what's the need? Okay, therefore, expectation of z. What is expectation of z here? Expectation of z is 0 plus 0 0.15 plus 0 0.12 plus no, not 0 0.12. It's, yeah, you do make mistakes like these, like I'm sorry. Okay, and then 0 0.15 multiplied by 7, that is 1.05, 1.05. So let's add them. 0 0.15 plus 1.05 plus 1.2, that is nothing but 2.4. Therefore, expectation of z equals 2.4, and that's the answer. Okay, I took a particular page because I thought that things would be that tough, but turns out that they are not. Okay, all right. Just a minute. 0.3 multiplied by 4, 1.2. Yeah, it's okay. It's perfectly okay. Now, we've got centered and spread. Now, what is centered and spread? Suppose you have got a lot of data set. Not a lot of data set. Okay. And you have to find a middle value. Why do you have to find a middle value? What's the need for finding a middle value? Well, the need for finding a middle value is to see how much does each value deviate from the middle value, or from its central tendency. Remember the keyword central tendency. The middle value is called the central value, and what is the central tendency of each of the values. Okay, so you find some value here. Okay, this you can call as center. And now for each value which is placed in this center, you can calculate how much are these values spread out from the center. Not in this fashion, sorry again. um yeah, from this center part. Okay, and since this value is always positive, okay, since this value is a distance, since it's always positive, and we cannot apply modulus. Why can't we apply modulus? A very obvious question, right? The main reason for that thing is we cannot apply modulus because at times we do not know what will the center actually be. For example, if I have got some arbitrary center x bar and I am applying it to like this, and this is the modulus. Okay, so in order to find out how much has it spread, if x bar, sorry, xi is greater than x bar, the modulus will open with um, a positive sign, and if it's not, then the modulus will open with a negative sign. A hell lot of confusion, right? So more computation. We don't want any more computation. So what's another way of doing it? Another way of doing it is simple, and it's just squaring. Okay. And to answer you guys, we do apply the modulus part, but in a different manner. We'll see it. But what is this quantity? This is nothing but the variance. This quantity is the variance. And why did I write summation in here? So that each and every, or sorry, or I have to, if I have to find out the um, total variance. Okay, if I have to find out the total variance of the data set, I have to sum it up, right? Otherwise, how will I be able to find it out? So this is something that is called variance, and this helps us in determining spread. Okay, all right. And remember the modulus thing? Yeah, the positive square root of variance, that is the standard deviation, which is nothing but the distance from the central value. Okay, so variance as a whole is more useful, and also so is standard deviation. I won't despise it. I won't despise this chap, but both of them are useful. And variance and standard deviation, hence variance and standard deviation, these are the things that help us in understanding the center and spread from the central value, from the center of the so-called data set, and that is known as the center and spread, and these are the two quantities. Okay, so we can write center and spread of a data set is determined by two quantities. What are they? Number one, variance, and number two, standard deviation. Okay. It's denoted by sigma squared, and standard deviation is denoted by sigma, obviously the positive square root. So it's that case. Okay. So how to calculate the variance of a random variable, not of a data set, but of a random variable? Well, it has got a simple formula, and that's something that you have to remember only. That is expectation of x squared minus expectation of x whole squared. Okay. What it does the same thing. I mean, expectation is the average. Take the measure of central tendency of each value, square it up, and then do its average. You'll be getting the average central tendency, and in that case you'll be getting this value if you manipulate it a bit and you apply some values or some concepts or some properties of the central tendency, but you don't have to remember them. Okay. All right. Now, standard deviation, what is this? There's a positive square root of variance, as I told you. Achha, this is also known as variance of x. Okay. So the positive square root of the variance of x, it is standard deviation. Or if I have to write it in a more proper manner, expectation of x squared minus expectation of x, its whole squared. And believe me, these two values, these two formulae will be used in majority of the cases, and this will be solving literally all of your problems because nothing's more than these things. Okay. Right. So this is known as the center and the spread. Okay. Now, some general properties of center and spread. What is the general property? I mean, you have to identify some general properties of variance and standard deviation. So for variance, there are only two properties which are very easy, or I should say three properties. Okay. I'll be discussing the third one, although it's um, ahead in this lecture. So variance, that will be the first property for variance, that will be variance of ax equals a squared, variance of x, where a is nothing but a constant. So expectation would only throw up the constant outside, but variance, since it itself is a squared quantity, it throws up the constant outside but with a square. A good chap, it converts every negative thing to positive. Whatever tries to convert it to negative, you can take it in that way. Okay. The second property, variance of x plus a, variance of x plus any constant, that is variance of x. Why is it so? Suppose I am adding some value, like say x, let x be something like what should I say? Sorry, let a be something like 1. Okay. So if I add up each term and if I take up its mean, what will it be? It will be nothing but a itself, that is 1. Okay. So xi minus x bar and its summation, say it is only for twice the case, and it's squared as well. Okay. So if I got a data set of 4, 1, 3 and 2, so what will it be? 4 minus 1 squared plus 3 minus uh, 1 squared plus 1 minus 1 squared plus 2 minus 1 squared. So this is 9, this is 4, this is 0 plus, what is this? This is 1, this is 13 as a whole. Now let's do okay, sorry, I've mistaken. 4 plus 1 5, 5 plus 3 8, 8 plus 2 10. So 10 by 4, that is 2.5. Okay, so 2.5 plus a, so that's nothing but 3.5. Okay, so 4 minus 3.5, 3 minus 3.5, 1 minus 3.5, 2 minus 3.5. Okay, so when I will be multiplying, or when I'll be adding these things, what will the value for this particular thing be? The value for this will be 0.5 whole square, that's 0.25, 0.5 whole square, 0.25 again. Sorry, it's negative 0.5. Okay, so 1 minus 3.5, what is it? 1 minus 3.5, that's negative 2.5, and that squared will be giving me 6.25 plus negative of 2 minus 3.5, 2 minus 3.5, that is negative 1.5, and it's squared, it's 2.25. So it's nothing but 0.25 plus 0.25 plus 6.25 plus 0.25, that is 9. Okay, all right. So this is something that has come out to be 9 taking this value. Okay, all right. So can you see that this value of 1, okay, this value of 1 was actually not needed in this place. Why? Since the value of 1 for this case, or if I added 1 in here, 1 to each and everything. So what will this be? 4 plus 1 minus 2.5 minus 1. 4 minus 2.5. What will that be? Mm, 1.5, right? Yeah. So if this was nothing but 1.5, sorry, 2.5 minus 1. If I would add each of them, then my values will be something similar to these cases. 1.5 is for this. It might be different for any other value, but the value that I'll be getting for this case will be the same. You can try it out if you want to. Okay, so if you are varying anything, does a constant vary? No, it does not. Right? You can remember this by only one single line. If you are varying something, the constant does not vary. So for that case, the random variable's variance, to be more precise, it does not vary, and hence variance of x plus a equals variance of a, where a again is a constant. Okay, all right. Then standard deviation of ax. What is this? Positive square root of variance of ax. So a into square root variance of x. So it's a into standard deviation of x. So this is nothing but a sigma x. Done. Simple as that. All right. So another thing, standard deviation of, acha, okay, this is for standard deviation. Okay, standard deviation, and standard deviation of a plus capital X. That is nothing but standard deviation of x. Why? Because it is nothing but variance of a plus capital X, and since variance of a plus capital X is variance of x, so it's as simple as that. Okay, all right. Now, as I had told you, these are some values of your data sets that will be given to you. Okay, uniform distribution, Bernoulli distribution, binomial distribution, geometric distribution, Gaussian distribution. This will be given in question number 2 of your answer or your question paper. Okay, all right. And similarly, continuous random variables. There are many things that will be given to you, and we will be exploring them as and when we deep dive. Okay. Now, standardized random variable. What is a standardized random variable? It is a random variable because you have nothing to understand it here. Having expectation or mean as 0 and variance as 1. Okay. Any variable which has an expectation of x to be 0 and the variance to be 1, it is standardized random variable. And at times we don't get a standardized random variable, and that's frequent. I mean, getting a standardized random variable is a matter of luck, but any non-standardized non-standard DARD standardized, just a minute, screwed up in my spelling, non-standardized random variable. For a non we get cases like non-standardized random variable and not standardized random variable. So for cases like non-standardized random variable, what should we do? We convert them to standardized random variables by a formula x, or the standardized random variable of these non-standardized random variables, as y minus expectation of y divided by standard deviation of x. And this is very important. Not now. Okay. You'll be studying something as a standard normal distribution. Okay. We'll be studying something like standard normal distribution, which follows x as y minus mu divided by sigma. Okay, so this is standard normal distribution, and you won't be feeling its impact right now, but in each and everything of hypothesis testing and all your central limit theorem and all of these things, this plays a huge role. Okay, so it's better if you learn it up at this point of time. Just learn it up, and you will be seeing this application in week 10, week 11, week 12, not in week 10, but definitely in week 11 and week 12, and some part in week 9 when you will be studying CLT, that is central limit theorem. Okay, all right, now let's do some questions. The first question: if Nidhi, if the probability that Nidhi will earn rupees 2000 on a particular day is 1/4, and the probability that Nidhi will earn rupees 3500 on the same day, same day is 3/4, what is the variance? Okay, we know it, it's as simple as that. Okay, let's find the PMF table. Let's do the PMF table. So x, that will be 200, sorry, 2000 and 3500, and then the probability, I'm writing it as p right now, okay, because you know it, what goes in here. So it's 1/4, and for this case it's 3/4. Okay, therefore if I have to find expectation of x, what is expectation of x? It is 2000 into 1/4 plus 3500 into 1/4. So that is 500 plus 3500 into 1/4. How much will that be? I have no idea. So let's just calculate it. It's 875. So 875. So what is the expectation? The expectation that I am getting for this case is 1375. Now let's define expectation of x squared. What should I do? Just replace x with x squared. Okay, that is from I equal to 1 to 2 xi squared probability of capital X equals xi. Okay, all right. So this is 2000 squared into 1/4 plus 3500 squared into 1/4. So no, not 1/4, it's 3/4. Okay, so 2000 squared into 0.25, sorry, 0.25 plus 3500 squared into 0.75. That is a huge number that comes somewhere around 101875000. So much money. Okay. Therefore, variance of x, what is it? Expectation of x squared minus expectation of x and its whole squared. So it's 101875000 minus 1375 whole squared, which is 101875000 minus 1375 squared. What is it? 1890625. 1890625. So 101875000 minus 1890625. So it is still 8296875. Right? Okay. All right. So this is the answer that you can expect. Okay. Um, am I mistaken in some place? Just a minute. 3500 into 3 divided by 4. It's 3500 into 3 4. Oh my god. Sorry. 3125. This will be 3125. This will be 3125. So for this case, it will be 3125. 3125. So 3125 squared, that will be 9765625. 9765625. Let me keep it chanting. Yeah, so it's 9765625, and when you subtract it, you will be getting an answer of 421875. And the calculation mistake I did, that is how you lose marks. So careful. What is covariance? Simple thing, a very simple concept. It is nothing. Covariance of x comma y is nothing but summation I equal to 1 to n x I minus x bar into y I minus y bar. Okay, all right. So uh, do we use it? No, we use something else. What do we use? We use expectation of xy minus expectation of x into expectation of y. You don't have to dive deeper into the derivation of the formula because it's not necessary. We have to find out the physical significance. Physical significance like covariance of x comma y. If it is lesser than 0, then either x is greater than e of x, that is expectation of x, or y is greater than, sorry, What did I do? If it's greater than 0. Yeah, maybe not. Okay, sorry. So y is greater than expectation of y. If it is lesser than 0, then either x is lesser than expectation of x, or y. Acha, this is not or. Okay, this is and, but this is or. Y is lesser than expectation of y, and this, if it's equal to 0, then x and y are uncorrelated I dot e dot independent, and since they are independent, the value will be nothing but um, uh, 0. And since it's 0, expectation of x equals x, and expectation of y equals y. Not and, you can say or. Okay, all right. That's all about covariance. And with this, we have a very simple yet a very important result, which I told that I'll be discussing, and now it is, that is variance of two random variables x plus y. It is given by variance of x plus variance of y plus 2 covariance of x comma y, but I doubt that you will be using it because we never used it in stats 2. Okay, all right. So properties of covariance, the same properties that I have told you right now, except some. Okay, what are those properties? Covariance is linear, that is covariance of ax plus by comma z is a covariance x comma y, x comma z plus b covariance y comma z. Okay, second, covariance of uh, x comma ay plus bz. Similarly, it is a covariance of um, x comma z, sorry, yeah, x comma z, or is it x comma y? Sorry, it is, no, it's x comma y, and this is y comma x. Sorry, x comma z. Yeah, x comma y. This is b covariance x comma z. Just um, replace each of them. Okay, all right. And for this case, it is covariance of x comma a covariance xy plus b into covariance of xz. Okay, simple as that. And if you know this, if x and y are independent, then what is it? Covariance of x comma y equals 0. Therefore, expectation of xy minus expectation of x into expectation of y, that is 0. So expectation of xy, that is nothing but expectation of x into expectation of y. Okay, so this is an important result that you must remember. Now we have a question. Which of the following which of the following operations are correct with respect to random variables? Covariance of xy equals expectation of x minus ex into y minus ey. Yeah, it is correct. Why is it correct? Because it is the average. So if you are asked the average covariance, this this is a correct answer. Okay. Similarly, covariance of x comma y equals expectation of xy minus, yeah, this is correct as well. Okay, yeah. Then covariance of ax plus by comma z. What is it? Ax. Yeah, this is also okay. This is oh, sorry, just a minute. Yeah, this is also correct. And covariance of xy 0, then x and y as independent arguments. This is also correct. So all correct. Okay, all right. So let me leave this to you as a homework. Okay, um, this is easy. You just have to manipulate. Yeah, remember one thing: expression of xy equals summation xy or xiyi into probability of x equals to small x, comma y equal to small y. Just remember this thing, compute it, and then comment the answer. Okay. For anything inside this place, just replace it with the entity outside the probability. A simple trick, but it can save lives, and it has saved lives. Okay. All right. So we have got a smaller part covered up. Sorry, we have got a smaller part left till now. It's correlation and then inequalities. A 5 to 10 minute lecture, which I'll be providing it to you in the next session. So let's wrap it up for this case in here. And thank you everyone. The recording has been too long, so that's the main reason I'm wrapping it up. So please pardon me for troubling you people, but this is important. Okay. So thank you everyone, and keep studying. Okay. All right.